So given a polynomial term of the form that is you have a ax power b, right, where a is constant, okay, coefficient, and b is also a constant, okay, which is an constant exponent, right? So let us take the derivative of this with respect to x. So d by dx of a x to the power of b, that will be b a x to the power of b minus 1. Okay, so let us look at few examples corresponding to them. So d by dx of 5x cube. Okay, so here which is related to a 5, which is a constant coefficient, okay, and b, which is 3, which is again a constant exponent. Okay, so this is 3 into 5 x to the power of 3 minus 1, so which is 15 x square. So let us solve this problem. So this is a here 6 is the coefficient constant, and the exponent a is 2 by 3, so it is 2 by 3 multiplied into 6 x to the power of 2 by 3 minus 1. Okay, so this after cancelling you get 4 x to the power of minus 1 by 3. So let us take this problem. This is d by dx of 3x to the power of half, or this is d by dx of 3 power half and x to the power of half. Okay, so this will be 1 by 2 into 3 to the power of half x to the power of minus 1 by 2, or you can write this as root 3 by 2 multiplied 1 by root x, or 1 by 2, this will be this, both are the roots, so this will be a root of 3 by x. Now let us solve this problem. So this will be again d by dx of 6x cube minus d by dx of 12x. So this is 18x square minus 12. Now let us find the derivative of this. So this is 4 multiplied 8 x to the power of 3, or this is 32 x cube. Okay, now this is minus 2 multiplied 5 x to the power of minus 3, or you can write this minus 10 by x cube. Okay. So let us solve this problem. So this is 7 by 4 multiplied into 8 x to the power of 7 by 4 minus 1. Okay. Or we can write this as 56 by 4 x to the power of 3 by 4, which results as 14 x to the power of 3 by 4. Okay. Now let us find the derivative of this. So this is 3 by 5 multiplied 1 by 6 x to the power of 3 by 5 minus 1, which is minus 2 by 5, and this results to 1 by 10 x to the power of 2 by 5. Now let us solve these derivatives. So 1 by root x can be written as d by dx of x to the power of minus half. Now this will be minus half into x to the power of minus half minus 1, which is minus 3 by 2, or can write this as 1 by this is minus 2 x to the power of 3 by 2. Fine. Now let us look at another problem. Let us solve this 5x cube plus 4x square minus 3x plus 2. Okay. Now let's solve this. Yeah. So of x cube plus 4 into d by dx of x square minus 3 d by dx of x, and then this is d by dx of constant. So this will be 3 into 5, which is 15 x square. This will be 4 into 2, which is 8 x, and this is minus 3. Okay, and the constant term is 0. And let us differentiate with respect to t. So d by dt of root t minus 1 by. So this can be written as d by dt of t to the power of half, okay, minus d by dt of t to the power of minus 1. Okay, so this will be t to the power of half is half t to the power of minus half minus this is minus t to the power of minus 2, or we can write this as 1 by 2 root t, and this is plus 1 by t square. So let us look at another topic. Okay, so if you consider the function f of u is a function of one variable, and u of x is itself a function of a second variable, which is x, then the chain rule may be applied in order to find a derivative of the function, which is f of u of x, okay, with respect to the second variable, that is, okay, d by df by dx is equal to df by du multiplied du by dx. So f of u, which is an outside function, and u of x is called the inside function. Okay, and the chain rule basically states that df by dx, which is equal to the product of the uh, uh, derivatives of the outside function and the inside function, that is df by du and inside function du by dx. Now, the product rule allows you to take a derivative of two different functions, that is f of x and g of x, okay, of the same argument, which is x, right? When the functions is multiplied together, f into g, so g into df by dx plus f into d by dg by dx. Okay, the quotient rule allows you to take a derivative of two different function, that is f of x and g of x, right, of the same argument, which is x here. Okay, when the functions are being divided, so d by dx of f of g is equal to g into df by dx minus f into dg by dx divided by g square. Now let us perform the following derivative with respect to x. So here by applying the chain rule, df by dx is equal to df by du multiply du by dx. So if you consider u as 2x square minus 5, so f of u will be u to the power of 5, so which is u of x is 2x square minus 5. Okay, so uh, this will be df by dx df by du multiplied du by dx. Okay, so this is d by du of u power 5 and d by dx of 2x square minus 5. Okay, so this is 5u power 4 into, this will be 4x, okay, or 220x, sorry, 20x u power 4, right? So this let us substitute what is u we have taken. So this is 20 into x, 2x square minus 5 power 4. Now here the variable is t, so differentiating with respect to t using again the chain rule. So u is equal to t cube minus 8. So f of u will be square root of u, which is u to the power of half, and u of t, which is t cube minus 8. So df by dt is df by du multiplied du by dt. So this is d by du of u to the power of half and d by dt. This is t cube minus 8, or now this will be u to the power of half, right? So it is half into u to the power of minus half. Okay, so this will be 3t square. Okay, and now when you substitute this, or let us rewrite this, root u 3t square, right? So u is t cube, right? So 3t square by 2 into root t cube minus 8. Now we'll make use of the product rule here. So f of g, f of x is 3x power 4 minus 7, and g of x will be 2x cube minus 6. So d by dx and of f into g, which is g into df by dx plus f into dg by dx. Okay, so let us solve this. This will be 2x cube minus 6, and this is d by dx of 3x power 4 minus 7. Okay, and plus 3x power 4 minus 7 and d by dx of 2x cube minus 6. So this results as 2x cube minus 6 into, this will be 12x cube, and this is 3x power 4 minus 7 multiply 6x square, or further simplifying, this is 42x power 6 minus 72 x cube minus 42x square. Now let us apply the quotient rule here. So f of x is x power 4, 3x square minus 6, and g of x is x square plus 1. Right? So d by dx of f by g, which is g into df by dx minus f into dg by dx divided by g square. Okay, so this is x square plus 1. Now the differentiation of x power 4 plus 3x square minus 6 would be 4x cube plus 6x and the constant, which is 0, minus f is x power 4 3x square minus 6 within brackets, and this will be 2x divided by g square, which is x square plus 1 whole square. Okay. So on simplifying this, get the final answer as 2x power 5 plus 4x cube plus 18x divided by x power 4 plus 2x square plus 1. Yeah, this is the final answer. I hope this was useful for you. Now let us solve this problem by applying chain rule. So let us consider u as 5t square minus 3t plus 6. Okay. Now f will the function f of u, which is 1 by square root of u. So this is nothing but u to the power of minus half. So let us find df by dt, okay, which is nothing but df by du and du by dt. Okay, so d by du of u to the power of minus half, okay, and d by dt of 5t square minus 3t plus 6, right? So this is minus half u to the power of minus 1 by 2 minus 1, which results minus 3 by 2. Okay, and this would result to 10t minus 3. Okay. So let us recall this u as 5t square minus 3t plus 2. So that will be, uh, this is minus half, this is 10t minus 3 divided by, uh, in the denominator you have 5t square minus 3t plus 6. So this is the solution. Okay. And let us solve this by with respect to x. Now we'll apply product rule here. So let us consider f of x here as 4x square minus 6 and g of x as root x, okay, which is x to the power of half. So d by dx of f into g, okay, which is g df by dx plus f into dg by dx. Okay, so this will be x to the power of half. Now this will results to 8x differentiation of this plus f. F is 4x square minus 6. Okay, differentiation of this will result to half, x to the power of minus half. Okay, so simplifying, we get 8x to the power of half into x plus this will be divided. So 2x square x to the power of minus half minus 3x to the power of minus half. Now this entirely, when you solve this, so this is 10x root x minus 3 root x by x. Okay, so that is the final answer. Now let us solve this problem by applying a quotient rule. Here f of x, we can write this as 3 minus 2x square and g of x as 4 minus 3x square, right? So d by dx f by g, which is g into df by dx minus f into dg by dx divided by g square. Okay, so let us apply this here. 4 minus 3x square. So differentiation of 3 minus 2x square, which is 4x, minus 3 minus 2x square, right? Differentiation of this would be minus 6x, right? So this divides by 4 minus 2x square whole square, right? So when you simplify this, the numerator becomes minus 16x plus 12x cubed plus 18x minus 12x cubed divided by, now this will be 16 minus 24x square plus 9x power 4, or further if you simplify, now these things get cancelled, right? So you will have 18 minus 16, which is 2. So 2x divided by the denominator. Right? Okay, so we'll solve another problem. Again, we'll apply chain rule here. So let us consider u as x cube minus 4x. So f of u, which is 1 by u to the power of minus 1. So df by dx is df by du and du by dx. Okay. So let us find that. Okay. So this is minus u to the power of minus 2, and uh, differentiation of this would be 3x square minus 4, which will be ns of 3x square minus 4 by u square, or can put this as minus 3x square plus 4 divided by u, which is x cube minus 4x whole square. So let us look at another type of problem here. So let us consider f of x as 4 plus x to the power of 9, and g of x as 2 minus x power f. So by applying product rule here, okay. So d by dx of f into g will be uh, that is 2 minus x power 5, and differentiation of 4 plus 9 to the power of 4 plus 9 x 4 plus x to the power of 9, right, which is nothing but d by dx of 4 plus x to the power of 9 and 4 plus x to the power of 9 and d by dx of 2 minus x to the power of 5. Okay. Again, here, if you look at this now, we can apply a chain rule here. So let us consider u as 4 plus x. Okay. So, and v as 2 minus x. So f will be u power 9 and g will be v power 5. Okay. So this is 2 minus x into um, d by du of u power 9 into d by dx of 4 plus x. Okay. So this is the first part, and this is power 5, and this is 4 plus x to the power of 9, and this will be d by dv of v power 5 and d by dx of 2 minus x. Okay, and then further, if you simplify, this is 9u8 2 minus x power 5 and 5v power 4 4 plus x power 9. Okay, so finally we get as 9 u, which we have taken 4 plus x power 8, and this is 2 minus x power 5 minus 5x plus 4 to the power of 9 and 2 minus x power 4. So this concludes. Okay, yeah. So let us solve another problem. Now we'll apply chain rule here. So u is t square plus 9 So f is square root of u power half, and df by dt, which is d by du of u power half, and d by dt of t square plus 9. So this will be half u power minus half. So this is 2t, and this is t by root u, or this is t by root t square plus 9. So that is the answer. Now let us apply a quotient rule for this. So f of x will be, this is x to the power of 4, right? And g of x will be square root of x square plus 4. Okay, so the quotient rule, so d by dx, which is f by g. So g, which is square root of x square plus 4, yeah, differentiation of x power 4 will be 4x cube minus x power 4 into differentiation of square root of x square plus 4. uh, that is, let us solve that separately. Power half, this divides x square minus 4, right, whole square. Now let us solve this part. So d by dx of x square plus 4 to the power of half. Okay, so let us consider u as x square plus 4, and this will be g if you consider root u, and u to the power of half. So this, if you consider this as dg by dx, okay, this is dg by du into du by dx, or or this is differentiation of u to the power of half is minus half u to the power of minus 1 by 2. Okay, and differentiation of u will be 2x, or can write this as x into this gets cancelled, x into uh, u, which is x square plus 4 to the power of minus half. So let us substitute it here. Okay. So further continuing it, so we got this result. Now this will be 4x cube square root of x square plus 4. This is x power 4, and we got this result x into x square plus 4 to the power of minus half. Okay, so this is x square plus 4. Yeah, yeah. So now after simplifying this and separating it, so let us separate all the terms. Now this the numerator can separate 4x cube by, this is root x square plus 4, yeah, minus, so this is x power 5. So x power 5 divided by x square plus 4 to the power of 3 by 2. Okay. Okay. So if you simplify further, and then we get, this is 3x power 5 plus 16x cube divided by x square plus 4 to the raise 3 by 2. So this is the final answer. Okay. So we'll solve another problem. Now in this problem, we'll apply the chain rule. So u as 2x to the power of 5 by 2 minus 8x to the power of 3 by 2. So f will be u to the power of 6. Okay. So df by dx is d by du of u power 6 multiplied d by dx of 2x to the power of 5 by 2 minus 8x to the power of 3 by 2. Okay, so this will be 6u power 5 multiplied, this is 5 by 2 into 2 x to the power of 3 by 2 minus 3 by 2 multiplied 8 x to the power of 1 by 2. Okay, and then for substituting u here, 6 into 2x to the power of 5 by 2 minus 8x to the power of 3 by 2, and this is 5x to the power of 3 by 2 minus 12x to the power of 1 by 2. Okay, yeah. Now let us solve this problem. So by applying the quotient rule, so here f of x will be x square plus 3x minus 4, and g of x will be 2x plus 5. Okay, so d by dx of f by g, so this is 2x plus 5 multiplied with this and the differentiation of this, so that would be a d by dx. This is 2x plus 3, right, minus x square plus 3x minus 4, differentiation will be 2 divided by g square, which is 2x plus 5 whole square. So after simplifying this, we get as the final answer as 2x square plus 10x plus 23 divided by 4x square plus 20x plus 25. So that is the final answer. And so one more problem. So let us consider u as 2 plus root x. Okay. So this is 2 plus x to the power of half. Okay. So f will be root u, that is u to the power of half, and then yeah, so df by dx is equal to d by du of u power half and d by dx of 2 plus x to the power of half, right? So this will be, if you solve it, so this is half u to the power of minus half. Okay, so this is multiplied into half into x to the power of minus half, right? So and then this is half into u, which is 2 plus root x, right, to the power of minus half. This is 4, 1 by 4, and multiplied x to the power of minus half, right? We can write this as 1 by 4, and it comes under the same root, so x into 2 plus root x. Okay, so this will be the final answer. Let us look at derivatives of trig functions. Okay, so the derivatives of the basic trig functions are d by d theta sine theta, which is cos theta, right? And d by d theta cos theta, which is minus sine theta, and d by d theta uh, tan theta, which is secant square theta, and d by d theta of cosecant theta, which is minus cosecant theta cot theta, and d by d theta secant theta, which is secant theta tan theta, and d by d theta cot theta, which is minus cosecant square theta. Okay, and let us perform some of the derivatives with respect to theta. Okay, so here are few. So let us see d by d theta of 4 sine 3 theta, right? Now let us apply chain rule here. That is u is equal to 3 theta. So f of u looks like 4 sine u. Okay, so u theta is 3 theta. Okay, so df by d theta, which is df by du and du d theta. So which is d by du of 4 sine u and d by d theta 3 theta. Okay, so which is this is 4 cos u and this is 3, so which is 12 cos u, which is 12 cos 3 theta. Now let us look at this problem here. Now this here we can use the quotient rule here. So f of theta, which is 1 plus sine theta, and g of theta, which is cos theta, right? So d by d theta, f by g. Yeah. So let us solve this. So this is cos theta. Now d by d theta of 1 plus sine theta, which is cos theta, right? And minus 1 plus sine theta, and this is minus sine theta. This is divided by cos square theta. Okay, so this is cos square theta minus this is let us open the brackets. So it is plus sine theta, and this is plus sine square theta divided by cos square theta. Okay, so this is 1 plus sine theta, because these two I can write as 1, and this is cos square theta. So that is the following answer. So let us look at another problem here. This is dx, d by dx. This. Okay, now let us apply the chain rule here. So u is equal to x cube. So f of u, which is 4 tan inverse u, and u of x is x cube. Okay. So df by dx is df by du and du by dx. Okay, so d by du of 4 tan inverse u and d by dx of x cube. So tan inverse is that is 1 by 1 plus x square, that is u square. Okay, and this is 3x square. Okay, so this is 12x square. Now u, which is x cube, so this will be 1 plus x to the power of 6. Okay. So here's another problem. Let us apply the product rule here. So let's consider f of x as sine inverse x and g of x as cos inverse x. Okay, so let's solve this, which is d by dx of f into g, right? So that is g, which is cos inverse x, into d by dx of sine inverse x, plus this is sine inverse x and d by dx of cos inverse x, right? So this will be cos inverse x multiplied 1 by square root of 1 minus x square plus sine inverse x, and this is minus 1 by uh, square root of 1 minus x square. Okay. Now this will be cos inverse x minus sine inverse x divided by square root of 1 minus x square. So that is the line result. So let us solve this problem with respect to theta. So applying the chain rule. So u is phi theta. So f is 7 tan u. Okay, so df by d theta. Okay, so that is df by du and du by d theta, which is this is with respect to u. So 7 secant square u, and this will be phi. Okay, so this is 35 secant square phi theta. Okay. So this is your answer. So let us again apply the chain rule here once again. So take u as sine theta. So f is 3u power 4. So df by d theta, which is df by du and du by d theta. So this is um, 3u power 4, okay, d by du of this, and d by d theta of sine theta. So this is 12u cube cos theta, which is 12 sine cube theta cos theta. Now here you have two functions, so let us apply the product rule here. So f of theta is cosecant theta and g of theta as secant theta. So so this is d by d theta of f into g, that is secant theta, d by d theta of cosecant theta plus cosecant theta and d by d theta of secant theta. So this results as secant theta, and this is minus cosecant theta cot theta plus cosecant theta secant theta tan theta. So after simplifying this, so this is secant theta and cosecant theta multiplied cot theta plus tan theta. And if you further simplify this, get the final answer as cosecant square theta plus secant square theta. Okay. Let us look at another type of problem here. Here you have the function inside the function, right? So let us take this with respect to theta, applying chain rule. So let us consider u as theta square minus 2 theta plus 4. So this is f is cos u. So df by d theta, which is df by du and du by d theta. So which is d by du multiplied cos u and d by d theta, which is theta square minus 2 theta plus 4. Yeah. So this is minus sine u. Okay. And this is 2 theta minus 2. And now when you substitute it, so let us substitute these things. So this is minus 2, can take it outside, theta minus 1, right? Sine theta square minus 2 theta plus 4. So this is the full answer. Now let us look at another problem. Let us apply chain rule here also. So u as root theta, which is theta to the power of half, and f will be 2 cot u. So let us find what is df by d theta, which is df by du and du by d theta. So which is d by du of f, which is 2 cot u, okay, d by d theta, theta power half. So this is minus 2 cosecant square u Okay, and half theta to the power of minus 2. Okay, so this will be now u as t to the power of half. So this is minus 2 cosecant square u, which is t to the power of half. Yeah, or let us root theta. Okay, and this root theta, right? So we can cancel this out and we can bring down cosecant in the denominator. So that we can write as minus 1 by, this is sine square theta, and multiplied into root theta, right? So this is the final answer. Okay. So let us solve this problem. Let us consider f of theta as theta, and g of theta is equal to sine theta, right? So again, this is a product rule here. So d by d theta, just f into g. So sine theta, and d by d theta into theta, plus this is theta d by d theta into sine theta. So which is sine theta plus theta cos theta. This is your answer. Now let us solve this problem here by applying the chain rule here. So consider u as root 1 plus sine theta, and f is root u, which is u to the power of half. So df by d theta, okay, so which is df by du, and du by d theta, which is d by du, u power half, and d by d theta 1 plus sine theta. Okay, so this is half u to the power of minus half, and this thing is 0 plus cos theta. Okay, so it will be 1 by 2 root u and cos theta. Okay, so which is cos theta by 2 root 1 plus sine theta. Yeah. So here's another problem. Now here we'll apply the chain rule. So quickly let us see this. So u is 4x, and f is 3 cot inverse u. So df by dx is df by du, and du by dx, okay, which is d by du of 3 cot inverse u, and d by dx of 4x. Okay, so this is minus 3 by uh, 1 plus u square, yeah, and this is 4. So finally we can write this as minus 12 by 1 plus 16 x square. This is the answer. Okay, So let us solve another problem, then close out. So here's another problem. Here, if you look at this problem, we can apply the quotient rule here. So f of x is secant inverse x, and g of x is x. So d by dx of f by g, right? So let us apply this. So x d by dx of secant inverse x minus secant inverse x, and then is d by dx of x. Okay, so keep it in brackets so that you won't lose. Okay, so now this is equal to x into, this is 1 by mod x and square root of x square minus 1, yeah? And this is secant inverse x and 1 divided by x square. Okay, so if you further simplify and can cancel out x, so that we can write it separately. So this one terms get cancelled, and so you will have 1 by x mod x and square root of x square minus 1 minus secant inverse x by x square. So here where mod x, right, which is greater than 1, okay, so which is the absolute value. Okay, so please do subscribe, okay, and look for more results. Please do pass comments on these so that I can do some more problems. Thank you for being with us.